Alright, lowest common ancestor of a binary search tree. Start. Given a binary search tree, find the lowest common ancestor of two given nodes in the binary search tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes V and W as the lowest node in T that has both V and W as descendants, where we allow a node to be a descendant of itself. For example, the lowest common ancestor LCA of nodes 2, 8 is 6. 2, 8, and the lowest LCA is 6. Another example is the LCA of nodes 2 and 4 is 2. Since a node can be descendant of itself according to LCA definition. So, I think what kind of information then can we take advantage of? So first of all, this is a binary search tree. So the attribute of a binary search tree is that the left node is less than the root, and the root is less than the right node. And the common ancestor is that. So another attribute is that if these two nodes fall into, say, this is, if I say 6 is the node. So if they fall into the same side, then the root is either one of these, right? If they are in the same side of a root. But anyways, so now, what can we do? Usually if we solve a tree problem, it's either recursion or iteration. So in this case, I would like to use iteration because iteration is more intuitive and more visual if you want to do binary search. So I'm going to do that. So first of all, if root is equal to null, then we'll just return. So first of all, we'll just return null. Well, actually return root. Well, actually, you know what? If root is equal to null, or root is equal to p, or root is equal to q, then we'll just return root, right? Means we found a root that we want. But if it's not, then we should split it. So if the root is less than, well, do we know the number? Do we know the quantity, the value of the PQ? Is it guaranteed that P is less than Q? I don't know. So if, say, root is less than P and Q is larger than root, then obviously I think this is the root we want, right? This is the root we want. So if not, or there's another situation, or root value, right? This is value is, so how do we say this? How do we say P is less than root and less than root? So root minus P dot value times root dot value minus Q value is less than 0. then we also return root, right? So either this one of the nodes is equal to root or these nodes. Let me see if it's correct. So these nodes, either one of these, so their value is less than, if their root is in between their values, then that's also the one we want. But is it the lowest though? Is it the lowest? Because for 7 and 8, 7 and 9, actually that's the lowest. That's the lowest that we want. What about 7, 3, and 5? 3 and 5 is all the way less than 5, 6. So that's what we want. Yes, so we got that. Now, if P and Q are both less than root, then we should traverse it to the left, right? So now what we should do is lowest. So we should get left. So we should totally just return, right? So say this, okay, if P is less than P value, you know what? I'm just going to do a return and lowest common ancestor. So if P value is less than root value, then we will put you know what, this is too long. I don't like that. So let's do tree node equal to, so if P value is less than root value, which means root left, we want to traverse to the left, and then else we want to traverse to the right. Okay, and in this case it's node P and Q. Return this value. Okay. Well, there's no testing, so I think this is good. So let's hope that this will work. Wait. Accept it. Oh, perfect. Great. Just 3 lines. Oh, right. Great. So anyways, it was pretty simple but kind of tricky minded. So anyways, thanks for watching. See you next time.